Hello guys, today I want to teach you how to find the Fourier series expansion or representation of f of x is equal to x in the interval 0 less x less 2 pi. So the first thing is to note the formulas for finding the coefficients. Okay, so the first coefficient is a naught, and a naught is equal to 1 over t integral from 0 to c plus 2t of f of x dx. N is equal to 1 over t integral from 0 to c plus 2t f of x cos n pi x over t dx. And Bn is equal to 1 over t integral from 0 to c plus 2t f of x sin n pi x over t dx. Okay, so we also note this formula, which is an interval of c plus 2t. And in our example here, we have this interval 0 less x less 2 pi. So we can insert that interval here. You realize that your c is 0, okay, and c plus 2t is just 2t, okay, which is 0 plus 2t, that is just 2t, and we have a 2 pi here, so that is just the interval from 0 to 2 pi. So that implies that your t is pi. Okay, so the first thing you have to do is to find the first coefficient, which is a naught, which is 1 over t is pi. Okay, integral from 0 to c plus 2t, which is 2 pi. Okay, f of x is x dx. Okay, this is just 1 over pi. Okay, integral of x is x squared over 2, 0 to 2 pi. Okay, and when you evaluate this, you will get a 2 pi. Okay, so the next thing is to find an, and an is equal to 1 over pi integral from 0 to 2 pi x cos n pi x over t, which is pi dx. Okay, so the next thing you have to do is to simplify this. We'll have integral from 0 to 2 pi x cos nx dx. Okay, so you realize that you have to use integration by parts to solve this. So integration by parts, integration by parts, which says integral of u dv is equal to uv minus integral of v du. Okay, so the next thing you have to do is to equate the relevant parts of the integration to your formula of the integration by parts. So we have our u, let our u be x. Okay, let our du, when you integrate this, you get dx. Okay, let our dv be cos nx dx. Okay, and our v will now be sin nx over n. Okay, so we come back and insert these values to our formula. So we'll have the integral of 1 over pi from 0 to 2 pi of x cos nx dx will now be equal to 1 over pi. Okay, so the first part is uv. Okay, and our u is x. Okay, sin nx over n, the interval is from 0 to 2 pi. Okay, and then you minus v du, and that is just 0 to 2 pi. Okay, sin nx over n dx. Okay, so you realize that the first part goes to 0 because sin 2 pi is just 0 and sin 0 is 0, so the first part goes to 0. So we remain with this part here. Okay, this is the only part we have to integrate for this. So we'll have the integral of sine nx is negative cos nx over n, and that one will now be a positive cos nx over n squared, and then we have our interval. Remember, we had a 1 over pi here. Okay, so we have our interval from 0 to 2 pi. Okay, and the first part, when we get our 2 pi inside cos nx, we have cos 2 n pi x, and that is just negative 1 raised to power 2, okay, minus 1 over n squared, because cos 2 n pi x is just negative 1 raised to power 2. Okay, so that is our cos 2 n pi when we insert n 2 pi in cos n. So we have a 0 here as our an. So our an is 0. So the next thing is to find our bn, and bn is integral 1 over pi 0 to 2 pi x sine nx dx, and we also have to use integration by parts here. Integration by parts. Okay, and we have integral of u dv is equal to uv minus integral of v du. So let u is equal to x, du is equal to dx, okay, and dv is equal to sine nx dx, and v is now equal to negative cos nx over n. Okay, so when we get our values inside our equation, we'll have 1 over pi, okay, negative x cos nx over n, interval is from 0 to 2 pi, plus 0 to 2 pi, okay, cos nx over n dx. Okay, and you'll realize that for the first part you'll insert x 2 pi to x, we'll have a negative 2 pi, okay, cos 2 n pi, okay, over n, and then plus we'll have a minus 1, which is a plus 1 over n, okay, and then plus sine, when you integrate this one you get sine nx over n squared, interval is from 0 to 2 pi. Okay, and your solution now will be, when you evaluate this, you will get a 2, because this is an even function. Okay, so you'll get a 2. Okay, so you'll get a 1 over n plus 1 over n, which is a 2 over n. Okay, but the second part, you'll get a 0 for the sine. For the sine, you'll get a 0, so we cancel this. For the cos, we get a 2n, okay, a 2n. So bn will now be negative 2 over n. So our expansion now will be f of x is equal to n0 over 2 plus summation from n is equal to 1 an cos n pi x over t plus bn sine n pi x over t. Okay, so we had our n0 as 2 pi, so 2 pi over 2 is pi, plus summation from n is equal to 1 to infinity. Okay, your n was 0, so this one will go to 0. Our bn was negative 2 over n, so we'll have a negative 2 over n sine nx, and that is our expansion.